squared. So we are starting off today talking about trig identities. So an identity is an equation that is true for all values of the variable. So I should be able to plug in any value and it's going to work out perfectly fine. So what they like to do is they like to ask you to prove an identity to be true. So that's what we're doing for these first couples. We're proving whether it's true or not true. So we have here x plus y squared. We're trying to see if it's the same as x squared plus 2x plus y squared. So what you have to do is you have to get both sides to be exactly the same. That's how you prove an identity to be true. So one way we could go about this is taking our x plus y, writing it twice, and multiplying. So I'll give you guys a minute. Let's have you multiply that out on your own. So when you first multiply out, you should have gotten x squared plus xy plus y squared. So when I combine my like terms, what do we get? Same exact thing. So we would still get our x squared plus 2xy plus y squared. In fact, does equal x squared plus 2xy plus y squared. So we have proved it to be true. There was another way we could have gone about that. Does anybody think that they know? You could factor this side, and after you factor, prove that they're true, which it would have worked out that way also if you had factored it. It would still have been x plus y squared. So example number 2, prove that the following is not an identity. So we're trying to prove that it's not equal to each other. So we could sit here and take x plus y, write it out 3 times, and then multiply. But that's not really the easy way. What I want to do is I want to help us practice factoring our perfect cubes, which is what we have over here on the right side of our equal sign. X cubed plus y cubed is one of our perfect cubes. So let's see who can remember. What's going to go in our first set of parentheses? Danielle? X plus y. Take the cube root of both your terms, and that goes in the first parenthesis. What goes in our second parenthesis? Yeah, starts with the first term squared, turns to a minus, multiply the 2 of them together, so we get xy, and then plus the last term squared. Now, could I factor x squared minus xy plus y squared again? No, that's not factorable again. So are these the same thing? No. So that's not an identity because it's not the same thing. So that's not going to work out every single time. So within our trig, we have a few different identities we need to memorize. Memorize. I talked about it just a little bit. Our cosecant is 1 over sine. Your secant is 1 over cosine, and cotangent is 1 over tangent. Those are our reciprocal identities. Our quotient identities would be your tangent is sine over cosine, and then cotangent is the reciprocal of that, which would be cosine over sine. So you got to memorize those. Because when you memorize those, we're going to use them in order to figure out our trig identities down here. So the directions will tell you to prove the following identity. So what you have to be able to do is, again, get one side equal to your other side. So in order to do that, first thing you want to do, put it in terms of sine and cosine. So once you get it in terms of sine and cosine, and then you want to simplify everything. So this is when we use our identities up above. So cosecant, if I look at my identities, is 1 over sine. So I'm going to change cosecant to be 1 over sine theta. Our secant, if we look up above, is 1 over cosine. And then it's times cotangent, which if I look up here, that's 1 over tangent. But my directions that I told you is I have to put it into sine and cosine. So we want to use this one down here, that it's cosine over sine. So I've changed everything into terms of sine and cosine. Over here on the right side of my equal sign, this is going back to our fraction rules. My cosines are going to cancel each other out because I got one in the top, one in the bottom. So on my left side, I have 1 over sine theta. My right side, we also have 1 over sine theta. So it works. So that is a trig identity. That is a true statement. All right, let's try number 2. I'm going to try to make this bigger. So we have cosecant A equals secant A over tangent A. So again, cosecant is what? Because one from the top, one from the bottom cancels each other out. That's our rule of fractions that we did all the way back at the beginning of the year. So cosecant changes into 1 over sine, so we have 1 over sine A. Secant is what? If we look up above, it's 1 over cosine. And then tangent is what over what? Sine over cosine. So again, I have to think back to our fraction rules. I have a fraction divided by another fraction. What do? No. Keep, change, flip. So my left side is still 1 over sine A. I'm not changing that one. So I'm going to keep it as 1 over cosine A. Change to multiply. Flip my bottom fraction. So it becomes cosine over sine. So now what can we cancel here? Cosines again. 1 from the top with 1 from the bottom. So 1 over sine A equals 1 over sine A. So again, these ones really aren't too bad. You just have to do your substitutions. You got to memorize what it is that you're plugging in there. Okay. So let's go to our next page. So recalling back from geometry, an angle is formed by the union of 2 rays. So you'd have one ray meets another ray, makes an angle. So we're going to be talking about angles in standard form. So we're going to be talking about our initial side, which is always at 0. On your x-axis, it's your positive x. So if I have my little coordinate plane here, your initial side is always this part right here. coterminal side is the other side of our angle. So your terminal side could end up in any of your 4 quadrants depending on how large your angle is. So to draw a little picture, let's say we had an angle like this. My terminal side is that side right there. Kind of where your angle ends. So next, this little guy, he's called theta. He's a Greek letter for angle. Next, a counterclockwise rotation. Again, we always start here. So counterclockwise means I'm going through my quadrants 1, 2, 3, 4. That's when you have a positive angle. It's like 75 degrees, 115, 280. You'd go counterclockwise through. A clockwise rotation, again, we always start at our initial side there. So you would go down first. That means you have a negative angle. So like negative 80, negative 110, you would go clockwise through. A quadrantal angle is an angle who lands on one of your axes. So an angle with a terminal side on an axis. So like for example, if it ended up here was your terminal side, so we'd have a 90-degree angle, 180, 270. Those are our quadrantals because they end up on your axis. And then coterminal angles, which we're going to be dealing with right now, those are angles with a common terminal side. So they share that terminal side. So when we go to draw our angles, which is what we're going to do next, we're going to draw our angles and then we're going to find our coterminal angles. You have to remember this side over here, that's our 0 degrees. We always start there. Up here would be 90 degrees, so that means any angle between 0 and 90 would be over there in our first quadrant. This one over here is 180. So any angle between 90 and 180 would fall in my second quadrant. Down here is 270. And then 360 shares that side with 0. And then it keeps going because you can have angles that are greater than 360. Just keeps going in those increments of 90. So when we're asked to draw the angle, so we have a first one, we have an angle of 320. So you have to think to yourself, 320 would fall between 270 and 360. So that means my angle is going to be down there in the fourth quadrant. And to show what angle we're talking about, we start at the initial side and we just draw an arrow going around, showing how we're getting to our angle. So that's a 320-degree angle. So then we have to find a coterminal angle to go with it. Yep. So our coterminal angles are usually angles that are going to be negative, and they're going to come from your initial side and go backwards through to meet your terminal side. So what ends up happening is your angle that you had and your coterminal angle have to add up to 360. So what's 360 minus 20? 40. And since we're going backwards, our coterminal angle is going to be a negative 40. Because 360 minus 20 is 40, and since it's going in a clockwise rotation, it's a negative angle. Because perfect circle is 360. Minus 320, because that's what the angle we had. All right, our next one, we got negative 140. So we got to go the other way around. We got to go clockwise. So this would be negative 90. This would be negative 180. So my negative 140 is going to fall somewhere in there. And again, we got to show with our little arrow which way we're going. So we got to find our coterminal. This time our coterminal angle is going to be a positive. Does anybody think they know what it would be? Huh? 220. Because 220 plus 140 gives us our 360. So now 540, that's higher than our 360. So I'm going to subtract 360 from it first. So 540 minus 360 gives us 180. So that means my terminal side is right here at 180. But when I go to show my angle, I got to loop around once and then go to 180. So it looks kind of like a little seashell on there. So what happens with this one is we've easily got two coterminal angles this time. One of them would be the 180 degrees, just going around once. That would be coterminal. Or we got the negative way, in which case it would be negative what? Negative 180. Now there's really even more coterminal angles than that, because I could just keep wrapping it around and finding more and more coterminal angles. All right, so negative 215. Let's figure out where we're going to land up. So we got 0, negative 90, negative 180. So my negative 215 will be up here in my quadrant 2. So what would be our coterminal angle there? $145. Again, if you can't think of it right away, just do 360 minus your 215. That gives you your other angle. All right, find an angle coterminal to negative 315. So let's draw our little picture. What quadrant would negative 315 fall in? Ooh. If it wasn't negative, it would be quadrant 4. But negative, we got to go backwards. Quadrant 1. So what would our coterminal angle be? .45. That little bit left. So in the other one there, find two angles coterminal to 500. So let's first subtract 360. Let's see where we actually end up. So 500 minus 360, what do we get? 140. So we are in quadrant 2. So again, they wanted two of them, two coterminal angles. What would our first one be? $140. We just figured it out. A 140 is one of them. Oh, close. What's 360 minus 140? So it's negative 220. All right. Coterminals. So now we're going to switch it up and talk about reference angles. So reference angle is an angle that is drawn from your terminal side to your x-axis. A reference angle is always between 0 and 90. So let's say, for example, here's my quadrant. I have an angle of 120 degrees. So there's my angle. My reference angle ends up being over here in the corner, those angles that we were dealing with last time. Your reference angle is always in between your angle and the x-axis. What does my picture end up looking like here? A right triangle. So you end up forming a right triangle using your x-axis, and it's always your x-axis. So since our reference angles are always between 0 and 90, if you have a quadrant 1 angle you're dealing with, your reference angle is just whatever that angle is. So if you're looking at angle 45, that's your reference angle. If you're dealing with a 60, that's your reference angle. When we're over here in quadrant 2, you would figure take 180 and subtract your angle measure from it. That gives you your reference angle, which again is this little angle right down here in the corner. If we are in quadrant 3, you would take your angle and subtract 180 from it. And again, that gives us our little angle there in the corner. And then quadrant 4 would be 360 minus your angle. That gives us our little angle up here. So of course the rules are a little bit different with our negative angles, but we'll get to those in a second. Let's practice some positive ones first. So we're going to find the reference angle for the following. When you're doing these, draw your little picture for now. That's going to help you solidify the concept here. So a 157 degree angle falls in which quadrant? Quadrant 2. So our rule up there was in quadrant 2, you would take 180, subtract your angle. That's going to give us our reference angle. So what's 180 minus 157? Is that 23? So our reference angle is 23 degrees. Now again, this is different than a coterminal angle. They're not sharing a terminal side. This is just your angle down to your x-axis. So 312, what quadrant would we end up in? The fourth. So our rule for the fourth is it's 360 minus 312. 48. So our reference angle would be 48 degrees. All right, 260, which quadrant? Third. So our rule for the third is the angle minus 180. So what do we get for that? 80. So our reference angle is 80. Let's do 6 before we do 4 and 5. So for 6, again, since we're greater than 360, the first thing we want to do is subtract 360. So 473 minus 360 gives us 113. So which quadrant is 113 in? Second one. So our rule of our second quadrant is 180 minus the 113. That's what I got. So 67 degrees would be our reference angle. So now for the other two, as I said, our negative angles are a little bit different. You kind of have to flip your rules a little bit. Negative 150 would fall in which quadrant? We'd be over here in the third quadrant. So our rule for the third quadrant is the angle minus 180, but that just doesn't make sense. That's just going to give us a bigger negative number. So you kind of have to flip it. Since the number's smaller than 180, you have to subtract it from 180. So our reference angle ends up being 30. Because again, we're finding this angle between here and your 80. So that's why you got to subtract them. No, if the number is more than 360, you first subtract 360 from it.
So if we're looking at it backwards, and it's negative, the spot that's 270 would kind of be like negative 90?
Yeah.
Wait, so basically,
That's what we're
It kind of like flips it. Yeah. But we're in quadrant 3 where the rule normally is the angle itself minus 180, but that just gives you negative, what is it, 330? So that doesn't give you a reference angle. Because this is negative 90, this is negative 180, so 150 is in between those. So which quadrant does negative 222 fall in? Quadrant 2. So how do you think we get our reference angle this time? It's like 400 something. 222 minus your 180. Again, you kind of flip it. So our reference angle ends up being 42. So again, your reference angle is this little angle between there and your 180. So that's why we're subtracting 180 from it.